Hey everybody, so in today's video we are going to learn how to determine formulas for compounds, and in the process we are going to draw the reactions that are occurring and learn how to write out the chemical reactions. So if we think about how this first happened, it first happened with gases, and so gases that formed compounds, they figured out that there were fixed ratios of components. So remember back when we did our simulation, we had our little container, and our container had a fixed volume here, and it would have a certain amount of gas particles. And if I had another container that was the same volume, it would have the same number of gas particles. So if I have the same volume, temperature, and pressure, I would have the same number of particles of gas. And so they were able to use that to actually figure out what made up compounds. So, for example, they figured out hydrogen and oxygen form water. So, if this is a hydrogen, and they needed 2 times the hydrogen gas volume. So, let's say this is my hydrogen, and this is my hydrogen, and this is my oxygen. They figured out this ratio. Every time water was formed, they needed double the H's to make water. So hydrogen, 2 components of those, 1 component of oxygen. Each of these has their own unique properties. Hydrogen has its own unique properties, and oxygen has different unique properties, but when they come together, they form a new compound, and that compound has a fixed ratio, and it has different properties than either of the originals. Okay, so there is our formula. Let's try it with something else. So ammonia is made up of 3 parts hydrogen, oops, and 1 part nitrogen. So, well, 3 of these and 1 of these. So when I put it together, the formula, the fixed ratio that never changes, is going to be NH3. So again, I've made a new compound. I see that I have 3 parts hydrogen, 1 part nitrogen, and I made ammonia. All right, but then something strange happened. They figured out that if I take 1 unit of hydrogen and 1 unit of chlorine, you actually make 2 HCl's. So it makes sense that you would make 1 HCl, but 2, that means you actually did this. I don't know why I keep getting this result. Sorry, you guys. Okay, if I get this, what the heck is going on? So what they figured out was something that we've actually talked about. Hydrogen is diatomic, which means you have to put 2 there, which means you got to put a 2 there, which means in nature, hydrogen does not exist on its own. It can buddy up, like here it is with chlorine, but it doesn't exist out on its own just as a single circle. It always has a buddy. Chlorine is also diatomic. So there it is. That one came together with one of these, and this one here came together with one of those. So they figured out H2 and Cl are hydrogen and chlorine are both diatomic. So there are 7 diatomic elements that we need to remember. I like to use the phrase 7 up because it helps you remember it. If this is the periodic table, there are 7 elements. It starts over here. N, O, F, C, L, B, R, I. See how this, oh my goodness, I don't know why I keep getting that weird text thing. I just want to write with my marker. See how that makes the number 7? And then up here in the corner is hydrogen. Those are the 7 diatomic elements. So that means all of those. So like if I wrote nitrogen, it would be N2. If I draw it, I draw 2 atoms connected. Bromine, Br2. Draw the 2 connected. Hydrogen, H2. Draw the 2 connected. Those are the 7 diatomics, and you have to remember them. Everybody else on the periodic table, everybody else is monoatomic. That means like gold, AU, just one circle. Na, sodium, just one circle. Lithium, Li, just one circle. All of those are monoatomic. But everybody, these 7, they are the only ones that are diatomic. They're the only ones that have 2 atoms that buddy up together. All right, so now that we know that, let's do hydrogen and oxygen and show water formation all over again. So this is an H2 and this is an H2. We still need double the amount of hydrogen compared to oxygen to make water, H2O. So here's my hydrogen, here's another hydrogen, and here's my oxygen. One O joins with 2 H's. The other O joins with 2 H's. So now if I want to write, that's drawing the chemical reaction. Now if I want to write the chemical reaction, I have 1, 2 of these H2s. So I put a 2 in front of it. Plus, I only have 1 O2. You never have to write O1 here because it's automatically a 1. You wouldn't write O2 unless you had at least one of them, and if you had more than one, you'd write the number. So nothing in front of it always tells you that that subscript is 1. And then I formed 1, 2 waters. So 2 H2Os. So that's our first chemical reaction. 2 hydrogen plus 1 oxygen makes 2 waters. And again, the properties of hydrogen and the properties of oxygen are different than the properties of H2O because this is a chemical reaction. I have formed a new compound. When you have a new compound, it has a new composition, which is new properties. All right, let's do it again. So this time, let's do ammonia. So we know that ammonia had 3 parts hydrogen. So let's do H2, H2, H2. Nitrogen's also diatomic, so N2. So 1, 2, 3 of these, and 1 of these. Each N takes 3 H's. There's another N, 3 H's. So this was NH3. And my formula, because I got to write the formula underneath, I have 1, 2, 3 of these. 3 H2s plus just 1 N2 makes 1, 2 NH3s. There we go, chemical reaction. Let's try again. So what would form from 1 unit of hydrogen and 1 unit of sulfur? So H2, and sulfur is not on our list of the 7 diatomics. So that means I just put an S. So 2 H's with 1 S would make H2S. And really, that's my chemical reaction. 1, 1, and 1. So I can just write it right like that. Let's try another. What would form from 3 units of hydrogen and 2 units of phosphorus? Okay. So I got H2, H2, H2. Phosphorus is P. If you're not sure about an element, just look the table S, the table after the periodic table. It lists out all of the elements' names and their symbols. So if you're not sure, that's where it is. Oh, I need 2 phosphorus. I should have made 2 boxes for that. That's okay. I'll put them right in the same box. Okay, so what works out here? If I have 2 P's and I need to distribute these 6 H's, I will give them each 3 H's. There. So I have made H3P. So my formula is 3 H2s plus 2 P's make 2 H3P. And I can make sure everything balances out. 3 and 2 is 6 H's. 2 and 3 is 6 H's. 2 P's, 2 P's. Perfect. And my picture shows that it all balances as well. All right, 2 units of magnesium and 1 of oxygen. So 2 Mg and 1 oxygen. Oxygen's diatomic. Can't forget my 7 diatomics. So there it is. So when I put those together, it looks like 1 blue will come together with 1 clear. 1 blue, 1 clear. So that means I have made 2 MgOs. So my formula, MgO, 1 of each. So there is my balanced equation. I needed 2 of these going in. I needed 1 oxygen, and I made 2 of these molecules, these new compounds. Let's try another. So if I start with CaCl2, all right, let's say Ca is an open circle, and Cl's, or I'm sorry, calcium is my blue circle, and my chlorine is like that. So what could make that? So I need chlorine. Chlorine's diatomic. So I need 1 of these, and I need a calcium. Actually, that just works out 1 to 1. 1 calcium and 1 chlorine that's diatomic will make 1 CaCl2. How about TiF2? All right, so T. All right, let's see. Ti is my filled in blue. Fluorine is diatomic, and I have 2 F's right there. So F2. There we go. All right, let's try another one. LiBr. Okay. So I'll make Li this one, Br this one. Okay. Ooh, Br is diatomic. So that means I'd actually have 2 of these. So Li. All right, what's going to happen? So if I have these 2 BRs connected, that means I'm going to need another Li here. So I'm going to put a 2 there because I'm going to need 2 of those. This will connect with the other BR, and I'll make 2 of those. There we go. Balanced reaction. Boom, boom, boom. And drawing. All right, Na2S. Okay. Na2S. All right, here's my S. Here's my 2 NAs. And let's go backwards. S is monoatomic. Na is monoatomic. So I needed 1 of these, and I needed 2 of these. I do not draw them connected, though, because they are monoatomic. So they get 2 separate circles not connected. So 2 NAs plus an S makes Na2S. All right, so that is the end of my video. From here, you want to go to Unit 4, Worksheet 2, which again, we're going to really focus on the gases in that one. Even though I just did a bunch that didn't include gases, we're going to focus on the gases for right now. So it's going to have you go through and do some more practice using hydrogen and oxygen and those kind of molecules. All right. Talk to you soon. Bye, peeps.